I want to present the topic leveraging graphics tablet and JPen library to detect essential tremor by authors Иван Осичук, Виталий Бреус, Dmitro Bishchak, Yaroslav Mashtaler, and Ivan Mudrik. This study aims to check if the selected system is suitable for diagnosing tremor at a given frequency, considering the challenges associated with its implementation and the obtained data, including the time component. An important part of any study is applicability. According to statistics, 4% of people 40 and older have essential tremor, and more than 1.2 million are affected by Parkinson's disease. A component of these movement disorders, as well as many others, is tremor. Since tremor has been known to people for a long time, there are certain methods of its diagnosis. This study is focused on the use of the Archimedean spiral drawing test. Previously, paper was used for this test, but using technology has improved its portability and ease. We used two models of tablets for the experiments, Bamboo and Canvas. An important characteristic of the tablet for the chosen task is the polling rate. Since different types of movement disorders have different tremor frequencies, the digitizer must be able to provide its table to be a diagnostic tool. Besides the tablet, we also need a software layer responsible for acquiring data from the device and saving it in the needed format. The table shows the technologies used to create it. Java was used to create the motion recording application, and the JPen library is the system's essential component which allows receiving events from the table and interpreting them into the language's data structures. Here is a diagram of how the motion recording solution works. A tablet communicates with the operating system through a driver layer. Providers as system-specific APIs are used to communicate with the tablet driver, such as WinTab for Windows. If a driver is unavailable, a standard Java AWT is used, which has less accuracy and not all types of data. JPen connects raw data with the motion capture solution, converting it into Java data structures. The trajectory drawn by a patient is displayed on the screen, and the data from it is saved into a file in a specific format. Next, consider the class diagram of the created program. The left side shows mostly the classes responsible for displaying a template and trajectory on the screen. The right side shows the classes for recording data. As a result, we get the data format shown. Absolute time shows the time in milliseconds when the event of pen position changing occurred since a tablet-dependent start time. Registered time shows the same moment but in the format of the amount of time since the start of the recording. Scheduled time provides information about the moment when the event was sent by the library. Two delta columns store the period between adjacent points. In addition to the coordinates, the tablet may provide information about the tilt or pressure on the pen. One of the problems with the data is the repetition of timestamps for different coordinates. An example of such repetition for the scheduled time can be seen in the table. To understand the picture, we visualized the points obtained for both tablets. The right part shows a significant number of steps representing different coordinates for the same timestamp. On the other hand, the left chart shows a smooth line with each coordinate having a unique time. This pattern is repeated along the entire time axis, but the intensity varies. In the right table, you can see the view of such data. We have unique timestamps and a set of individual points with this timestamp. The left table shows the statistic of the number of such points for each unique registered time value. The data from the WinTap diagnostic tool was also taken for comparison and marked as WT kept in the table. The left side of this table defines the timestamp group with the corresponding number of different coordinates. On the right is the number of such groups. As can be seen, all registered points from Bamboo have a unique timestamp. In turn, one unique time point for Canvas is rare, as there is a significant duplication of time values for coordinates. The frequency is calculated based on the first and the last timestamps and the total number of points. This way we can get the frequency that tablets really provide. The maximum period is obtained as the maximum value from the registered delta column, and in total 15 experiments were conducted for the Java prototype data and 24 WT kept. Both tables show aggregated statistic for this data with the median taken for each component. In conclusion, the created custom motion capture system provides efficient data retrieval and the ability to customize and preprocess the data. Both tablets can be used to diagnose essential tremor because their frequency, even when duplicated, is higher than that defined for the essential tremor up to 10 Hz.